Okay, right? For this one, this positive, it goes up, follow this arrow, goes through the load, cannot go that way, you must go this way and then return. Whereas this one, it goes positive here, come here, go through the load, cannot go back to the original place. Right? This is reverse bias already, so it cannot flow. So wrong answer. Okay. B, correct answer. Okay, any question? Will not give you any more tests. They'll try to finish for you quantum physics, and then we will try to use the rest of the time, if we still have time, to go over with you gravitation, and then heat topic. How do you guess? Temperature, thermodynamic, thermal properties, and then after that, SHM. Right? We try to review all that rather than start a topic. Since you will be, I'll be retiring at the end of this month. You also can ask me for help. I will still be working.
I'm so sad you're leaving us.
Time to retire lah, but you can still ask for help. I can still go to Zoom these days, very easy one. Can you use Zoom to help you? You just tell me you want to ask a question, and we just open a Zoom when you are free. Okay, that's the reason. I don't know who is teaching you yet from July onwards, but I'll try to find out for you. But I'll still be basing on the Facebook. Right? I'll still be working on the past paper. And if you still need help, you can still ask for help, no problem with me. I will still be keeping my mind active. Won't be completely retirement for me. Just like retirement is less stress. College more stress. So I miss Samuel. Okay, let us carry on. Okay, yesterday we were here. Sorry, need to share screen again. Okay, let us finish our photoelectricity. So Friday, remember tutorial, we'll go over AC and electromagnetic induction. After that, you can try the question on quantum physics. And if we still got time, we will go back to our gravitation, SHM. Okay, experiment, as I say, this is called your photocell. That is the symbol. You don't draw that, just draw the symbol. Okay. Question, why is the cathode make that way? Curve like that, rather than just a flat piece? Anyone? Yep, anyone?
So that the electron will move to the...
Okay. Two things. One, you have to curve it. You cannot have it flat. If you have flat, it cannot fix into the glass.
Oh, yeah.
Second,
I make scale looking at that.
Correct. What you say is correct. You want the electron to be emitted and then converge onto the anode. Right? That is the reason. The main reason. The other one is because it cannot, if you make it flat, it cannot fit in, it cannot go into the glass envelope. Okay? But the main reason is you want it to curve so that all the electron emitted will go to the anode. Okay? Photocell is an evacuated transparent glass bulb enclosing two electrodes. Now you got the anode, or sometimes it's called collector, which is usually maintained at positive potential. Right? It's positive, so it collects the electron that is emitted by the cathode. Then the cathode, sometimes some people call it emitter, is made of photosensitive metal. It can be zinc, can be cesium, depending on what you want. usually negative potential. Okay, so investigate how the current passing through the tube depends on the PD across the cell. Okay, so in this case, you have to look at the battery. This is positive, so it's connected to anode. Negative connected to the cathode. The voltmeter is to measure the potential difference across the photocell. And because the current is very small, we must use microammeter. Okay, so this part, the anode is to collect the electron. Electron emitted by cathode is collected by the anode. So usually we use ultraviolet light. And then the cathode made of zinc. It's important to specify it. Increase the voltage, read the voltmeter reading, and ammeter reading. And then after that, we want to reverse it. Change the battery direction. You can use this one to show it's a variable power supply, or you can use a resistor, variable resistor connected to a battery. Right? Remember, in this case, the negative is connected to the anode, positive is to the cathode. So this one is basically, remember it's negative, electron is emitted by the cathode, it's being pushed back. Push back. You want to stop the electron from reaching the anode. Okay? Right? This one, the power supply is reversed. Cathode is positive, right? You want to attract the electron back. Right? This is what we call stopping potential. That means we want to measure the maximum kinetic energy. Okay, let me define for you stopping potential. Okay, same. I'm just drawing differently. Right? The cathode is now positive. You want to attract the electron back. Remember, the electron is emitted with a range of velocity. So you need to have a certain voltage. Right? We call it stopping potential or cut-off voltage. Right? So this is the maximum voltage that will stop the electron, or that means you can't see any current. Right? If the voltage, if the electron is not collected by the anode, there's no current flowing. That's what we want, stopping voltage or stopping potential. So stopping voltage is the negative voltage that must be supplied to stop all electron from reaching the collector. Okay? Collector is the anode. Okay. So how to calculate it out? This is your ASO, work done. Right? From the definition of potential difference, sorry, a lot of things distracting me. Right? That's your maximum velocity, that's the mass of electron, and then there's your stopping potential difference. And we are just using the definition for voltage. So maximum kinetic energy equals to work done. No? That's the formula we use to calculate our maximum kinetic energy of the electron. Okay, and then same thing. That's how we draw our graph. Okay, that's how we draw our graph. You can change the frequency, and measure the kinetic energy again. Okay, by measuring the stopping potential. Okay, so I won't go over that with you. I've done that with you already earlier. So we can use stopping potential, can draw the graph that way, that's all. Same thing. Right? What does the y-intercept on the graph? Mark F0. Where's your F0? Anyone? Where's the F0? Yep, just applying your knowledge, that's all. Just applying your knowledge. Anyone? Yeah, it's still the same graph. It's still the same graph as this one. Right? I just replace this one with your With that, that's all. Yeah, kinetic energy I replace with that. And then rewrite the equation. Yeah, which is this graph. Replace it with EVS. So where's your F naught? You still get the same equation, same graph. Okay. Right? You just divide by E, that's all. That's your F naught. And then your gradient is H divided by E. X-intercept is F naught. Right? We just look at the equation, same thing. There's your Einstein's equation. Yeah, Einstein photoelectric equation. Replacing your EK max with EVS. And then divide by E. By E. And compare the equation of straight line. That's all. Okay, Ken? Okay, uses not necessary lah, but just for your extra information, right? That you want your photograph is very blurred.
So you can go back one slide.
Go back one slide. I'll give you more information in the PowerPoint where you can read. Usually that one it doesn't come out in paper 4 lah. Whether it will come out or not, I'm not sure. But so far it has not come out. Older one, yes. Long time ago, yes. But if you want, you can just review through, maybe for the sake of paper 5. Okay, I still have paper 5. You can ask your new teacher to teach you paper 5. That is the only topic. But other than that, we are almost comfortable. I think by August, you should finish everything already. Then you can do the partial paper. So that's the good news for you.
So why the voltage the gradient is H divided by E?
You replace this one with EVS. This one, EVS, this one, then divide by E. This one divide by E, this one divide by E.
Oh, yeah.
Okay, was fine already. Okay, not? Hey, any more problem? Teasing you. Don't get angry at me. Just teasing you.
No problem, sir.
You are a nice guy. That's why I like pull your leg. This afternoon, I will be giving the practical class DC circuit and electric current. So you want to join in, you are free to join in. You want to revise the topic, I will give them the quizzy. You want to join, you join anytime. You are free to join as a revision. I think I'm done with you, I'm not sure. Okay, where is the use in photo multiplier tube? Yeah, where your photograph is very blurred. If the time is up, let me know. Right? If the photograph is very blurred, you can photograph got light coming in, right? Reflected light. It goes in, it produces electron, and then you multiply the number of electron. Then this can be used to, this photo multiplier tube can use to restore your old photograph. That's the uses. Right? A single photon can produce a lot of electron and then increase the intensity. Right? The other uses is you go to supermarket or shopping complex where the person maybe staying inside and you open the door there, then there's a sound there. Right? Why? Because you are cutting off the infrared beam. Infrared beam there. As long as the infrared beam is there, the current is flowing. There's a photocell there. So when you cut off no current flow, then you make an alarm, let the person know that somebody is coming in. Right? Or you can also, if you are staying in a bungalow, right, you want to make sure that if somebody has climbed over your wall, then you can see on the CCTV. Right? Let you know. Right? You put a beam of infrared around your fence. The person doesn't know. So when he come in, he cut the beam. Then there's a warning to the owner of the house that there's an intruder. Okay, seen that in my friend's house last time when he was staying in a bungalow in Katakamuning. Okay, so that's the users. So we have more or less completed this part. That is where we have what is photoelectric emission. Oh, sorry. Time is up. Thank you, Eric, for letting me know. We will stop here. You can go for our next class. We see you on Friday. Okay, thank you. For those who got time, you want to stay back and ask questions, you can stay back. For those who got a class, you better go.